Welcome to the Deep Dive. If you're navigating the world of software or business, and maybe you're looking to boost your confidence and fluency in English, especially when the conversation turns to tech, well, this deep dive is definitely for you.
Absolutely. We're here to help you build that vocabulary, understand these kind of crucial tech concepts, and really see how they fit into the bigger business picture.
That's the goal. Because the language around technology, particularly fast-moving areas like cloud computing and AI, it can feel a bit overwhelming sometimes.
It really can. But understanding the key terms, it's like having a map, isn't it? We want to give you that map today by looking at a very practical scenario.
Exactly. We're going to unpack some essential terms related to moving to the cloud and exploring AI. And we'll do this by following the journey of a fictional company.
Let's imagine a company, we'll call them Bright Data Solutions. Now, like many businesses today, they reached a point where they needed to upgrade their core systems. So they decided to explore the possibilities of the cloud and maybe even, dip their toes into artificial intelligence.
Okay, so for the next few minutes, we're going to track Bright Data's progress.
Mhm.
We'll look at the decisions they made, the technologies they considered, and pull out the most important words and phrases as we go.
And the aim isn't just textbook definitions. It's about helping you understand how these terms are actually used in conversation.
Right, so you can feel more confident discussing these topics yourself, whether that's in a meeting, reading an article, or just listening to a presentation.
Think of it as getting practical language skills directly from a business context. So where should we start? Why did Bright Data make that first big decision?
Good question. Okay, let's unpack this. The very first step for Bright Data Solutions was figuring out why they needed a change. They had what we call legacy systems.
Legacy systems.
Yeah,
Basically, their older existing tech setup, right? Probably running in their own office or a data center somewhere.
exactly. So why make the leap from that to the cloud?
Well, the core drivers for Bright Data, as they looked into it, were really all about agility and efficiency. They zeroed in on two key benefits they wanted: scalability and elasticity.
Scalability and elasticity.
Okay.
And this all connects back to the main concept here, the cloud.
Right, so the cloud. At its simplest, it just means delivering computing services, things you normally do on a computer or server in your building, like storing data, running apps, using processing power, but doing it over the internet.
So instead of owning and managing all that physical hardware yourself, you're essentially accessing those resources remotely from a big provider.
Precisely. So when Bright Data decided to move their legacy systems to the cloud, they were moving away from managing their own physical servers. Now, about scalability, this term is absolutely crucial in business tech discussions.
It really is. It means the ability to easily increase or decrease your computing resources. Think servers, storage, processing power based on your actual needs, right?
Exactly. So if Bright Data's business suddenly took off, maybe their website traffic spiked, they could quickly add more resources in the cloud.
And importantly, if things slow down, they could reduce those resources too, which leads to a major business benefit: cost.
Definitely. You often pay for what you use, so better scalability can mean much better cost management.
So you might hear someone in a meeting say something like, "We need a platform with better scalability to handle future growth without a massive upfront investment."
That's a perfect example. And elasticity is closely related, but it takes it a step further. It's not just the ability to scale.
Is it the automatic adjustment, like in real time?
Exactly. Like an elastic band, as you said before we started, it automatically stretches under load and snaps back when the pressure's off. This is incredibly useful for handling unpredictable traffic.
Right, so imagine Bright Data runs a marketing campaign that unexpectedly goes viral. Elasticity would mean more servers automatically spin up to handle the surge without someone having to manually intervene.
Correct. So you might hear elasticity is key for handling unpredictable peak traffic efficiently. It avoids over-provisioning resources just in case.
Okay, so the why is clear.
Yeah.
Use scalability and elasticity for better cost control and performance. So what next for Bright Data? They had to figure out who would provide these cloud services.
That's the next logical step. This led them to evaluate different cloud service providers.
Ah, the big names.
Hmm.
Companies with the massive data centers and infrastructure to offer these services, like AWS, Microsoft Azure, Google Cloud, those ones.
Those are the main ones, yeah. And choosing a provider is a significant business decision, not just a technical one.
And part of that decision involves understanding the different ways cloud services can be delivered, doesn't it? the cloud delivery models.
Yes. These models basically determine how much of the tech stack, the infrastructure, the platform you manage versus how much the provider manages for you.
Okay, this is where we get those acronyms people throw around. IaaS, PaaS, and SaaS. They describe different levels of service, essentially.
Let's break them down, starting with the most foundational. ISS, which stands for Infrastructure as a Service.
Infrastructure, so the basics.
Exactly. With IaaS, you're essentially renting the fundamental building blocks, virtual machines, we'll touch on those more later, storage, networking over the internet.
Okay, so it's like renting the land and the raw materials. You get the core resources, but you're still responsible for building the house yourself, installing the operating system, the software, managing all that.
That's a good analogy. So you might hear someone say, we decided on an IaaS model for this project because we need full control over the operating system and the environment.
Right. Makes sense. What's the next level up?
That would be PaaS, Platform as a Service. Here, the provider manages the underlying infrastructure, the servers, storage, networking, and they provide tools and environments for developers to build and deploy applications.
Ah, so using your analogy, it's like renting a house that already has the kitchen fitted and maybe some basic furniture. Developers get a ready-to-go setup.
Precisely. They can focus purely on writing code and building their application without worrying about managing their operating system or patching servers or any of that stuff.
So the developer might prefer this, saying something like, our team prefers a PaaS solution because it speeds up our deployment process significantly.
Exactly. And then the final level, the highest level of abstraction is SaaS, Software as a Service.
SaaS. This one's probably the most familiar to people, even outside IT, right? It's just ready-to-use applications delivered over the internet.
Yes, like your web-based email or maybe a CRM system like Salesforce or project management tools like Asana or Trello. You access them through a browser or an app.
You don't install anything, you don't manage anything, you just use the software.
Correct. Businesses use tons of SaaS applications. So you might hear, we subscribe to several SaaS applications to manage our customer relationships and internal comms. Understanding IaaS, PaaS, and SaaS helps clarify what level of service you're talking about.
Okay, delivery models covered. But Bright Data also had to think about where these cloud resources would actually, live and how they'd be managed. The deployment models.
Right. Another key decision. There are three main options here, too. The most common one is the public cloud.
Public cloud. So resources are shared among lots of different users or companies over the internet.
That's it. Your applications and data run on infrastructure owned by a provider like AWS or Azure, and that infrastructure is logically shared among many customers. It's often the most cost-effective and easiest way to get started.
So you might ask in a planning meeting, should this new service be deployed in the public cloud for maximum cost efficiency?
Exactly. Then on the other end of the spectrum, you have the private cloud.
Private, meaning dedicated.
Yes, the cloud infrastructure is dedicated exclusively to a single organization. This could be managed by the organization itself in their own data center or by a third party, but it's solely for that one company.
Why choose that? More control, security.
Often, yes. Strict security requirements, maybe industry compliance regulations, or specific performance needs might make a shared environment unsuitable. So you'd hear, our sensitive financial data is kept in a private cloud due to strict industry regulations.
Got it. And the third one mixes them, right? Hybrid cloud.
Correct. A hybrid cloud is simply a combination of both public and private cloud resources designed to work together.
So companies might use this for flexibility. Keep some things private, put other things in the public cloud.
That's a very common strategy. Maybe keep sensitive data and core legacy apps in the private cloud, but use the public cloud for new web applications, handling variable traffic spikes, or for disaster recovery purposes.
Sounds flexible, but maybe more complex to manage.
It definitely can add complexity, managing resources across different environments, but you'd hear people say things like, we're implementing a hybrid cloud strategy to maintain control over core systems while leveraging the public cloud for customer-facing services.
Okay, great. So Bright Data has made these big strategic calls.
Right.
Why move? Scalability, elasticity, what services to use, DS, PaaS, tracks, and where to deploy, public, private, hybrid. Now comes the really technical part, actually moving their stuff.
The cloud migration.
Exactly, the cloud migration process itself. And doing this smoothly requires careful planning and the right tools to minimize disruption to the business. The source highlights several technical concepts Bright Data likely used. First up, containers. Containers. Okay, I hear this term a lot. They're like standardized packages for software.
That's a good way to think about it. They are standardized, lightweight, portable packages that bundle up an application's code and everything it needs to run libraries, system tools, all the dependencies, settings, everything.
So the big benefit is consistency. It runs the same everywhere.
That's the magic. It runs the same way on a developer's laptop, on a test server, in the old data center, or in the cloud. This portability makes moving and deploying applications much, much easier. Developers would say, we're packaging our app in containers for easier deployment across different environments.
Okay, but if Bright Data has loads of these containers, maybe hundreds, managing them all manually sounds like a nightmare. Starting them, stopping them, checking if they're healthy, scaling them.
You're absolutely right, and that's exactly where Kubernetes comes into the picture.
Kubernetes, another big one. It helps manage the containers.
Yes, Kubernetes is an open source system originally developed by Google, now managed by a foundation specifically designed to automate the deployment, scaling, and management of containerized applications. It basically orchestrates all those containers.
Orchestrates, like a conductor for an orchestra of containers.
That's a perfect analogy. It keeps everything running smoothly, ensuring the application is available, scaling it up or down as needed. Someone managing the infrastructure might say, Kubernetes helps us manage our containerized applications at scale, ensuring high availability.
High availability.
Yeah.
We'll come back to that. What other tech did Bright Data likely use during migration?
Well, they almost certainly made extensive use of virtual machines, or VMs, and the underlying technology, virtualization.
Okay, VMs.
Mm.
These aren't new, but they're crucial in the cloud, right? They're like software versions of a physical computer.
Exactly. A virtual machine is essentially a software emulation, a copy of a physical computer. It runs its own operating system, Windows, Linux, whatever, and its own apps, just like a separate physical box. But it's all software running on a more powerful physical server.
And virtualization is the tech that makes that possible, letting one physical server host many VMs.
Correct. Virtualization allows a single physical server to be split into multiple isolated virtual servers. This is absolutely key to maximizing the use of expensive hardware. It's fundamental to how cloud providers operate efficiently.
So you might hear someone say, we spun up a new VM in the cloud to host the database, or more generally, virtualization is key to our infrastructure strategy. It increases hardware utilization.
Precisely. Now, beyond just efficiency, Bright Data obviously needed to ensure their systems were reliable once moved, and crucially, that data wasn't lost.
Absolutely critical. Which brings us to redundancy and backup.
Yes. Redundancy simply means having duplicate critical components or even entire systems. If one part fails a server, a network switch, a disk, a backup takes over immediately, ideally without any interruption.
Like having two engines on a plane or a spare tire in your car.
Good examples. And backup is maybe more straightforward. It's about creating copies of your data and systems so you can restore them if something bad happens. Hardware failure, human error, a cyber attack.
So you need both. Redundancy for immediate failover, backup for recovery after a disaster.
Ideally, yes. Both redundancy and backup are essential strategies for achieving high availability.
Ah, there's that term again. High availability. That just means the system is up and running and accessible most of the time, right?
Exactly. It's usually measured as a percentage, like 5 nines, which is 99.999% uptime. Businesses need their critical systems to have high availability. So you definitely hear phrases like, we built in redundancy for critical services to ensure continuous operation, or ensure you have a robust backup strategy in place before migrating the database.
It's total sense.
Mm-hmm.
Okay, so Bright Data's core systems are moving to the cloud, becoming more reliable. What about those AI ambitions we mentioned?
Right. As the foundation got stronger, new opportunities opened up. Their data science team started exploring the world of machine learning.
Machine learning or ML, a subset of AI?
Correct. Machine learning is a technique where computer systems learn from data to identify patterns, make predictions, or make decisions, but without being explicitly programmed for every single possible outcome. They learn from experience, essentially.
And how did the team work on this? The source mentions notebooks.
Yes, cloud-based notebooks. These are interactive computing environments, very popular in data science. They let you write and run code, see the results immediately, visualize data, add explanatory text, all in one document. They're great for experimenting and collaborating.
So a data scientist might say, let's share this notebook so we can collaborate on refining the algorithm.
Exactly. The team also experimented with pre-trained models.
Pre-trained,
Yeah.
meaning someone else already did the initial training.
Yes. A pre-trained model is an AI model that's already been trained on a massive data set. often by a large research lab or tech company, usually for a general task like recognizing objects and images or understanding basic language structure.
So you don't have to start from scratch. That sounds like a huge advantage.
It is. It saves enormous amounts of time and computing power. You can often take a pre-trained model and then fine-tune it with your own specific data for your particular task. The team might report, we started with a pre-trained model for image recognition, which significantly sped up our development process.
Okay, and then their ambitions grew even bigger, looking at large language models or LLMs.
LLMs, these are really at the forefront right now. They are incredibly advanced AI models trained on truly vast amounts of text and code. Think, pretty much the entire internet and more.
And this massive training allows them to understand and generate human-like language really well.
Impressively well. They can write text, answer questions, summarize documents, translate languages, even write code.
And Bright Data specifically looked at using an LLM for automating customer support.
That's a very common use case. They might discuss, we're exploring LLMs to handle common customer queries automatically through our website chatbot.
Okay, but how do you connect something complex like an LLM to their existing chatbot system?
Good question. That's where APIs come in.
API, Application Programming Interface. I know this one. Sort of. It's like a way for different software systems to talk to each other.
That's exactly it. Think of an API as a contract, or a set of rules and definitions that allows one piece of software to request services or data from another piece of software in a standardized way. It's the glue that connects different applications.
So Bright Data used an API provided by the LLM service, allowing their chatbot software to send a customer's question to the LLM and get the generated answer back.
Precisely. You'd hear the technical team say, we use the API to integrate the LLM into our existing customer support platform. APIs are fundamental to modern software development.
And maybe parts of this new AI-powered system, like the function that calls the LLM API, could run using serverless computing.
That's a very likely scenario. Serverless computing is a cloud model where the cloud provider entirely manages the underlying server infrastructure. Developers just write and deploy code snippets or functions.
And the cloud provider automatically runs that code only when it's needed and scaled it.
Exactly. The provider handles allocating the compute resources, scaling up if there are many requests, scaling down to zero if there are none. You only pay for the compute time you actually consume.
So it seems great for unpredictable workloads, like maybe chatbot requests, which might spike and then drop off.
Perfect use case. Bright Data might decide this chatbot function runs serverless, so we don't need to manage any servers for it, and it automatically scales with traffic, which is cost effective.
Okay. This whole journey sounds amazing, moving to the cloud, exploring AI. But what about the fundamentals? Security, making sure they're following rules.
Absolutely critical. Throughout this entire journey, security and compliance would have remained top priorities for Bright Data, non-negotiable.
Right. So in the cloud, how do you manage security? A key part must be controlling who can access what.
Definitely. That falls under Identity and Access Management, or IAM.
IAM. Okay, what does that involve?
IAM includes the policies, the rules, and the tools used to define and manage user identities, who someone is, and control their access privileges, what they're allowed to do, within the cloud environment.
So making sure only the right engineers can start or stop servers, or only specific applications can access sensitive customer data.
Exactly. It's about enforcing the principle of least privilege, giving users only the permissions they absolutely need to do their jobs. So you'd hear things like, we need to review the IAM policies to ensure only authorized personnel can access the production database.
And when you're relying on an external cloud provider, you need some guarantees about their service, right? That's where service level agreements or SLAs come in.
Yes, SLAs are crucial. An SLA is essentially a contract between Bright Data and their cloud provider. It formally defines the guaranteed level of service performance, availability, support responsiveness, and other aspects.
And it often includes key metrics like guaranteed uptime.
Yes. Uptime, the percentage of time the service is promised to be operational and accessible, is usually a core component of an SLA. Understanding your SLA is vital for managing risk and expectations. A manager would definitely ask, what does our SLA say about uptime guarantees for this critical service?
Makes sense. You need to know what you're paying for. Okay, last piece. How did Bright Data keep track of whether all this effort, the migration, the AI stuff, was actually working and delivering value.
They needed visibility. The project manager and probably various teams likely use a dashboard.
A dashboard.
Yeah,
Like in a car, but for business data.
pretty much. A dashboard is a visual display, often web-based, that brings together key metrics and data points in one place. It gives a quick, easy-to-understand overview of system performance, project status, or key business outcomes.
And metrics are just the specific things being measured.
Correct. Metrics are the quantitative measures used to track performance or progress. For Bright data, this could be technical metrics like system uptime, application response time, latency, cloud service costs.
Or business metrics,
Yeah.
like user engagement with the new AI chatbot feature, or maybe customer satisfaction scores.
Exactly. Tracking these key metrics on a dashboard helps ensure the project stays on track and ultimately delivers measurable business value. So you'd hear, check the project dashboard for the latest metrics on system performance and cost savings. Understanding these terms helps you see how businesses measure the success of these tech initiatives.
Wow, okay. So reflecting on Bright Data's journey gives us a really practical way to understand all these important terms. We started with the big strategic move to the cloud, driven by needing scalability and elasticity.
Right. Then we looked at how they chose their approach, considering different cloud service providers, understanding the cloud delivery models, IaaS, PaaS, SaaS, and the deployment models, public, private, hybrid cloud.
Then we dove into the technical side of the actual cloud migration, touching on things like containers and Kubernetes for managing applications, the efficiency gained from virtual machines and virtualization, and making sure everything was reliable with redundancy, backup, and aiming for high availability.
And then there are exciting steps into AI, using tools like notebooks, leveraging pre-trained models to get started faster, exploring powerful large language models, LLMs, connecting things with APIs, and maybe using serverless computing for efficiency.
All while keeping a laser focus on security and compliance, using IAM policies, understanding provider guarantees through SLAs, and uptime commitments.
And finally, keeping track of it all with dashboards showing key metrics to measure success and value.
Mastering this vocabulary really is a powerful step if you want to feel more fluent and confident navigating these business and technology discussions in English. Hopefully, seeing how these words fit into Bright Data's story gives you, our listener, a much clearer picture of what they mean and, crucially, how you might use them yourself.
Absolutely. And this whole scenario, particularly that combination of scalable cloud infrastructure and really advanced AI like LLMs, it does raise a fascinating question to think about, doesn't it?
What's that?
Well, how is this convergence going to fundamentally reshape industries? What entirely new kinds of jobs or even whole business models might emerge just from leveraging these powerful technologies together in new ways?
That is definitely something interesting to mull over. A great final thought. For everyone listening, don't hesitate to maybe listen to this deep dive again to help reinforce these terms. Notice them in your work.
And maybe even try using one or two in a conversation this week. Practice is key. Keep learning, keep exploring.
And join us next time for another deep dive.